Hi people, notes 4.2 are on solving quadratic equations by square rooting. And just a quick note, do not square root until you have isolated the perfect square. So for example, if we were to solve the following equations, the first equation that we have right here, our perfect square is x squared. And because this x squared is completely alone, my x squared, my perfect square, is completely isolated. So I am allowed to go ahead and solve by square rooting. So I'm going to square root on both sides. And the answer to this is 4. And the reason why the answer is 4 is if I take 4 and I square it, I get 16. 4 times 4 is 16. However, it's not the only answer that I can actually multiply by itself to get 16, because a negative times a negative is also going to give us a positive 16. So actually we have two solutions, and our two solutions are negative 4 and positive 4. I just want to show you another way that we could solve this that would show us that the answers would be negative 4 and positive 4. So if I have x squared equals 16, if I wanted to solve this by factoring, I could subtract the 16, because when I factor, I always need equals 0 on one side. And then this is a difference of perfect squares, and I would have x plus 4 and x minus 4, which means that my two solutions would be negative 4 and positive 4. So this is more work. This is easier, significantly easier, but you have to remember that there are always going to be two answers whenever you square root. Okay, in number 2, 25x squared equals 49. This time, the perfect square is not isolated because of this 25 right here. So I cannot square root until I get this x squared fully alone. So to get rid of the 25, I would divide both sides by 25. So that means x squared equals, now 49 and 25 are not evenly divisible, and I can't reduce it. So I'm going to leave it as 49 over 25. Now in order to solve for x, I have to take the square root, which means that x is equal to the positive or negative. So right here, in the last example, we got x equals 4 and x equals negative 4, or we could just say x equals plus or minus 4. Okay, either way is perfectly fine to write this out. So I get plus or minus. Now, when I do this right here, it's 49 over 25. But really, technically, I can just say it's the square root of 49 over the square root of 25. And the square root of 49 is 7. The square root of 25 is 5. So that means that my two solutions are negative 7 over 5 and positive 7 over 5. And I'm done with this question. All right, so now in number 3 right here, our perfect square that we're looking at here is this whole entire x minus 1 squared. So that's what needs to get isolated, which means that I have to divide everything through by 2 because I don't want this 2 here anymore. And when I do that, I still have x minus 1 squared is equal to 72 over 2 gives me 36. At this point in time, I'm now allowed to square root. I was not allowed to square root before because this 2 right here throws things off. But here I can square root because this perfect square is completely isolated. So here I get the square root on both sides, which means that I end up getting x minus 1, because when you take the square root of a square, the square root and the square cancel each other out. That's the reason why we did this. And the square root of 36 is 6, but I could get plus or minus 6. Now pay very close attention to this next part right here. Now, in order to solve for x, I would have to add 1 to both sides. It does not matter what side you, where you place the 1. So I could either say plus or minus 6 plus 1, or I could say 1 plus or minus 6. It doesn't matter, but usually we say 1 plus or minus 6. Why do we write it like this? For one reason, it's usually just convention. That's just conventionally how things are done. But also, it's a lot easier to see what's going on here, because what this is saying here is that it would either be 1 plus 6 because of this plus part right here, or I would get 1 minus 6 because of this minus part right here, which means that my solutions are going to be 7 or negative 5. So here I can say my answers are negative 5 and 7. I like to put the smaller number first, but it doesn't really matter. Either way will work. All right, people, in number 4, same thing. I can see here that my perfect square is right here, this x plus 2 squared, which means that I do not want this 27 here anymore. So I need to divide everything through by 27. Whatever I do on one side, I do to the other side. So I end up getting x plus 2 squared is equal to 3 over 27. I can't divide 3 by 27 evenly, But I know that I can reduce this. They're both divisible by 3. So when I divide 3 by 3, I get 1. When I divide 27 by 3, I get 9. So right here, I get 1/9 is equal to x plus 2 quantity squared. Now, because this whole thing is just a perfect square, it's isolated, I can go ahead and square root on both sides. But don't forget, when you take the square root of something, your answers are going to be positive and negative. And I'm going to just square root each number. So the square root of 1 is 1, and the square root of 9 is 3. So I get plus or minus 1/3. And that's equal to this x plus 2. Okay, now to solve for x, I'm just going to subtract the 2 from both sides. And here I get x equals -2 plus or minus 1/3. So let's bring this up here. Notice it doesn't matter which side the x is on, so I just change the sides. So here, this means I get -2 plus 1/3. And here, this means I get -2 minus 1/3. Well, in order for me to be able to do this, I need to get a common denominator. So my common denominator here would be 3, so I'm going to multiply by 3. In the numerator, I get -6. And then I'm going to add 1/3 to that, so that gives me -5/3. And then over here, same thing, I'm going to multiply by 3, multiply by 3. I get still -6/3 because these are the exact same numbers, but this time I'm going to subtract 1/3. So I get -7/3. So my answers are -7/3 and -5/3. Again, it doesn't matter what order you write your answers. I just typically prefer to write the smaller number first. Okay, people, number 5 is the last question that we're going to look at. And this one's a little bit trickier, so I just want to talk about a couple things really quickly with this one. So our perfect square is this x minus 7 squared. So I'm going to divide everything through by 4. And I end up getting x minus 7 squared is equal to 6. Now, in order to solve, I have to take the square root on both sides. So I get x minus 7 is equal to plus or minus the square root of 6. Now, when I try to take the square root of 6, I can't take it evenly. I get an irrational number. Let's take a look at what this number looks like. So if I take the square root of 6, I end up getting this 2.449489743 number here. And it ends, but actually it doesn't. It only ends because Desmos is just like, nope, that's enough digits. We don't have any more space to write any more digits. But this number actually goes on forever and ever and ever. So because you cannot take the square root of 6 evenly with a rational number, we have 2 different ways that we would write our answer out. But we're not quite ready for that yet, because first I have to get rid of this 7. So let's go ahead and get rid of this 7. So I get 7 plus or minus the square root of 6. So here are my 2 answers. I either get 7 plus the square root of 6 or 7 minus the square root of 6. Do you notice how I still am keeping it as the square root of 6? Because I can't square root this evenly. So these are considered our exact answers. Why are these exact answers? Because I cannot write out the square root of 6 ever. If I tried to start writing it out today, I could go through and I would try to write out all my values. So I would get 2.449489, and I'm using actually my phone to do this, and my phone is showing a lot more values right here than Desmos did, but it still ends because there's just not enough space on the screen. And if I were to try to write out these values, I would start today and I would never be able to finish writing out all the values until the day I die, because this number will never end. So I can't write an exact value by writing out decimals. In fact, the only way that I can write out my exact answer is by leaving it as the square root of 6. This is my exact answer. So my 2 values are 7 minus the square root of 6 and 7 plus the square root of 6. Either way, either order is totally fine to write out your answers. This is one answer and here is the other answer. Now, to get an approximate answer, I'm going to actually type this into my calculator and see what I get. And typically when it asks you for an approximate answer, it usually asks you to round to something. So we'll round to the nearest hundredth. So let's go ahead and see what this is going to look like. So my first value is going to be 7 minus the square root of 6, which is 4.55, blah, 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 blah. I look at the 5, there's a 0 that comes after it, so the 5 stays a 5, so it's 4.55. And then for my other value, I get 7 plus the square root of 6, and I get 9.449, blah, 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 blah. The second 4 is in the hundredths place right here. So I look at what comes after the 4, it's a 9, so that bumps the 4 up. So let's just write this out so you can kind of see what I mean by this. So if you look here, this is the hundredths place. The 0 comes after the hundredths place. It tells us to keep this to a 5, keep it as a 5. So our answer here is approximately 4.55. This is one way that we could write approximately. Another way is with an equal sign with a dot on top. And so here, this is my hundredths place. There's a 9 that comes after it. So that 4 bumps up to a 5. So I get 9.45. So my two solutions are 4.55 and 9.45 as approximate solutions. And then these right here are exact answers right here. And that's it. Let me know if you have any questions. See you later.